everybody, here are your day 2 notes for multiplying and dividing radical expressions. Today we're going to focus on dividing radical expressions. So feel free to get that note sheet back out that you have and record the notes that we presently are going to write on here with dividing radical expressions. So let me scroll down on this page and show you an example. So we looked at multiplying earlier. Now we are going to do dividing. So this is called the quotient property of square roots. Quotient means division, okay? And so for any real numbers where a and b, a has to be greater than or equal to 0, b has to be greater than 0, we divide. So let me give you an example. I wrote up here the square root of 75/9. So I see a division in there. I see a fraction bar, which is division. This is actually equal to the square root of 75 divided by the square root of 9. And I can separate those out. That's perfectly fine because I'm taking the square root of both of them still. You might want to take that step because now we can simplify each down. So if we think about 75, think of the perfect square that's in there, the biggest one. So if I think I've got 4 doesn't work, and then that's 2 squared, 3 squared is 9, 4 squared 16, 5 squared is 25. 25 is my biggest square I can put in there. So let's go ahead and rewrite that. That would be 25 times 3. Consider 3. 3 doesn't have any perfect squares. I can't take any out. 9's perfect square is 3. So I can reduce the square root of 9 to the number 3. So I'm just going to rewrite it because 9 square root and 3 are the exact same thing. So we can simplify this down just a little bit more. Let's turn this 25 into 5 and bring it out. So I'd have 5 on the outside, square root of 3 over 3. That is how we're going to leave our answers. If you put that in on a calculator, you are going to get a crazy decimal irrational number. Your answers have to be in simplest radical form today. So this is called simplest radical form. You may not write these as decimals, and the radical has to be simplified down as pull out as many perfect squares as you can to get it to simplest form. Now, if this was a 6 on top, and let's just say the answer was actually 6 square root of 3 over 3, you can divide these two terms because they are compatible, and you could have 2 square root of 3. Now, that was not my answer, but just as an example, because they're both on the outside, that is an allowable thing. That was not the answer for this problem, but that you can do that. All right, lastly at the bottom, rationalizing the denominator. I'm going to talk to you about that in a little while, so we're just going to write C notes. We're going to do that after we practice dividing a little bit. Rationalizing the denominator means you may not have a radical in the denominator. It's not good form. So we have to figure out how do we get the radical, the square root expression, out of the denominator. And I'll show you how to do that. All right, so here is my first division problem. I still have my perfect square chart over there for you in case you need to use it. So I've got my first problem up here. Let's go through this problem together. I have the square root of 10b divided by the square root of 5. Now I can go ahead and expand some of this out. So I can have the square root of 10, and then it's b squared can have its own square root. It's all the same thing. And remember, in here I am multiplying, so I can write it like that over the square root of 5. I'm going to write that under the 10 because those are actually like one another. Because there is no variable in there, I can actually divide those because there's no number on the outside, and they're like each other, and I can do 10 divided by 5. So if I take 10 divided by 5, I get 2. It's in a square root, but I would get square root of 2. And then I can undo b squared, right? B squared, I can pull it out as b, and I can put it on the outside over here. So my final answer would be b square root of 2. I don't have any denominator, but that's my final answer for this one when I simplify it all the way down. So as a reminder, you are allowed to divide radicals that are compatible with one another, but keep them in the radical. Now, if this didn't end up being 2 here, if that was like a number I could reduce, let's say it was, I don't know, 64 or something, I could take the square root of that and break it down farther. But I can't reduce 2 in any fashion, so this is simplest radical form right here. Simplest radical form. Okay? That's how we have to leave this. The next one from your book is -6 plus the square root of 120 divided by -2. Now, I see an addition sign in here, and that's fine. And this is not -6 divided by -2, and then 120 is by itself. It is not that. That -2 actually distributes to this term and that term because it's underneath the whole thing. So the first thing we should probably do is simplify down the 120 into simplest radical form. So let's figure that out using our chart. What is the biggest number that can go in here? I know 4 can go into 120, and that is actually the biggest radical that can go in there, which is kind of crazy. So it is 4 times 30. 30 doesn't have any square roots in it, perfect squares at least. 4 comes out as 2, so this is actually going to be 2 square root of 30. All right, now, that is equal to that. They are the same thing. So let's rewrite this with my reduced radical on it now. I have -6 plus 2 square root of 30, and I'm going to write it a little different. I'm going to give this 2 to each term, -2, -2, and I have to do that because it's not applying to just the -6. It is applying to the other one as well. So let's go ahead and reduce these. I can go ahead and do this division. -6 divided by -2 would be +3. Then there is a plus sign, and I can actually divide here. I can divide the outside number by the -2. So 2 divided by -2 is -1, and then I still have my square root of 30. That 2 on the bottom cannot go into 30 because it's not a radical. I can write this maybe a little neater because that's perfectly fine. But I could also write 3 minus, I don't need that 1, square root of 30. Or I could write 3 plus negative square root of 30. Those are actually all the exact same thing. And any are acceptable answers for this problem. All right, a couple more to go. Oops, missed. All right, next problem. I have a radical in the denominator. Let's see what happens as we do this, okay? So let's fix 120 again. Hey, it's the exact same thing that we literally just had. So it was, if we remember back to our last slide, 2 square root of 30. So that's the same thing, okay? So I need to multiply these two together. So I'm going to have 6 square root of 30 over the square root of 6. Now, if you remember from the beginning when I started, I said you're not allowed to have radicals in the denominator, but it's going to fix itself right here. These are like terms. They're both radicals. I can divide them. I can't do the 6 on the outside and the radical 6. They're not like, but I can take the 2 radicals and divide them. 30 divided by 6 is 5. So I'm going to have a square root of 5. So those I did. And then I just have a 6 left on the outside. That becomes my final answer. And again, now I don't have a radical in the denominator. So we are okay now. Okay? All right. The next one, number 9, is 8 square root of n minus m square root of 18. That's kind of crazy. Divided by square root of 2m. Now, nothing here looks quite compatible. Because I have an m in one of mine, I have just a number, and I have a 2m, which does make them all slightly different from one another. So I need to do something called rationalize. And what that means is we need to get the radical out of the denominator. Okay, so get radical out of the denominator. All right, to do this, you multiply the top and bottom of your fraction by the denominator. I'm going to write that down. So let's write it over here. Multiply top and bottom of fraction by the denominator. Let me write it and then explain why it's acceptable. So I'm going to do the denominator square root of 2m, and, oops, make that bigger, square root of 2m. So I want you to multiply the top and bottom by the denominator. Well, that's the denominator. Couple things. We are first of all allowed to do this because the square root of 2m divided by the square root of 2m is 1. Anything divided by itself, it doesn't matter what it is 1. And multiplying anything by 1 is still that number. So number 1, this is allowed. And number 2, when I do this, it will get, and we'll do it now, but it will get the radical out of the denominator. And you'll see as we work through it. All right, so here we go. We need to multiply that one times square root of 2m, and that one, and that one. It's like distribution. It applies to all the terms. So 8, maybe I'll write a little more. Square root of m times the square root of 2m minus, there's a subtraction sign, minus m square root of 18 times the square root of 2m divided by the square root of 2m times the square root of 2m. All right, let's do that math and do that on. By no means do you actually have to write that step, but that is what we are doing. All right, so for this part, these radicals are like, so I'm going to have 8 on the outside, and then I'm going to have 2m squared on the inside, minus. I can now multiply the radicals again, so I'm going to have m. 18 times 2 is 36. And then just an m, because there's not an m here for it. And then a division bar. And 2 times 2 is 4. M times m is m squared. That's all under a radical. All right, so we're okay so far. So let's keep going on this one. All right. Remember what I told you in the last problem? This applies to both problems. So let's go ahead and see how this ends up working out. Actually, maybe let's simplify the denominator first. 4m squared, 4 comes out as 2, and m squared comes out just as m. This whole thing is just equal to 2m. Awesome. Okay? 2m, no radical sign anymore because they were both perfect squares in there. So let's go ahead and write each of these as such. So I'm going to have 8, the square root of 2m squared divided by 2m, and I'm going to have to do a little more simplifying, minus m square root of 36m divided by 2m. Now, hopefully you've seen that there's a couple more things I actually have to fix. This first fraction here, this m squared has to come out as m, so that's going to come to the outside. I'm going to rewrite it again, trying to give you some extra work. So let's rewrite that. So I have 8m square root of 2 divided by 2m. And then here, 36 is a perfect square. That actually comes out as 6, so that's going to come out here. So I have 6m square root of m divided by 2m. All right, oop, that's a lot of bumps in my m. All right, that's a lot of work. Let's keep going. Let's see what we can divide. Like terms, they sure look a lot alike. 8 divided by 2 is 4, and these m's cancel. M divided by m is 1. They're gone. I still had a square root of 2. And then the m's are going to cancel here again, but 6 divided by 2 is 3, and I'm left with a square root of m. These are not like terms to one another, because square root of 2 and square root of m are not like. So my final answer is 4 square root of 2 minus 3 square root of m. All right, I got a couple more problems because I think this is tricky. I have a radical in my denominator again. I must rationalize. Okay? So we are going to, if you remember, multiply the top and the bottom by the denominator, the square root of 8a over the square root of 8a. Let's go ahead and multiply that. So remember, it distributes here to each term. All right, 2, and then 2a times 8a would be 16a squared. There's a plus sign then. 4 on the outside. 8a times a would be 8a squared. All over 8 times 8 is 64. 8 times a is a squared, square root. Let's go ahead and simplify some of this stuff down then, and then we'll divide. This is a perfect square. 16 is 4, and a squared is a. So I just need to multiply these. So I have 8a, there's a plus sign. 8 can be simplified down a little bit. That is it's going to come out as, well, let's actually write it over here. It's going to be 4 times 2a squared. So the 4 is going to come out as a 2, and the a squared is going to come out as an a. So they're gone. I'm left with just a 2. So this is going to turn into 2a squared root of 2. And then this is also a perfect square. It's going to be 8a, all over 8a. So I'm going to go ahead and start dividing now. Oops, you know what? I missed something, everybody. I took out this 2, but I didn't multiply it times the 4. This is actually an 8 here. Let me go back to that. I took this out as 2a squared root of 2, but I forgot to multiply it times the 4. See, mistakes can happen. We're fixed now, though. Okay, we're fixed. All right, so let's divide. So I have 8a plus 8a squared root of 2, and they're both divided by this 8a. Well, 8a divided by 8a is not 0. Anything divided by itself is 1, plus this 8a and this 8a is also 1 square root of 2. You can write it like that, or you can have 1 plus the square root of 2. Both acceptable answers. But again, we're rationalizing the denominator. All right, I think this is the last. 2 more, actually, 2 more. All right, let's do it again. Multiply the top and bottom to, let's write the word again, rationalize. We're going to multiply top and bottom by 5 square root of b. 5 square root of b, and again, that is allowed because that is just a form of 1. All right, 5, let's distribute this one first. So I'm going to have 5b squared, that's in the radical. Let's do this one. I'm going to have a plus sign first. 10, and then I'm going to have another 5b squared. Over, and let's multiply these. I'm going to have the square root of 25b squared. All right, let's break this down a little bit. This one comes out as just a b, and this one does too, just as a b here. And then this is 5b. All right, let's break her down. I'm going to have 5b, and I was left with just a square root of 5 here. I'm going to have 10, a plus sign first, 10b, and I was left with just a square root of 5 here. Division bar, all over 5b. I'm going to go ahead and bring that out right away here. Okay? Let's divide. This is 1. Square root of 5 plus 10 divided by 5 is 2, but the b's cancel. So 2 square root of 5. Now, you should see something a little different here. They're both square root of 5, which makes them combinable. So I have 1 plus 2. I'm going to have 3 square root of 5. That's my final answer. Again, it's called rationalizing the denominator. All right, last problem. I ran out of paper. I see a radical in the denominator. I'm going to go ahead and multiply the top and bottom by square root of 11. Again, this is called to rationalize. It is bad form to have a radical in the denominator. All right, 13 times 11 is 143. So I have the square root of 143 over 11 times 11 is 121, all in a radical. 121 is a perfect square. It is 11. So this just turns into 11. I will give you a really big hint. 143 doesn't have any perfect squares in it. So my final answer is 143 and a square root over 11. That is your lesson for division of radicals. Good luck, everyone, and I miss you all, and hopefully I get to see you very soon.